Welcome. Thank you for joining me for the beginning of Chapter 2. So, in this lesson, Relations and Functions, we are going to talk about the ability to graph functions and to identify functions. Now, the first bit of vocabulary that I want you to know is a relation. And a relation is a set of inputs and outputs. When we think of inputs and outputs, typically we're thinking of X and Y. We're inputting an X to get a Y out. Another way to think of Y is f of X. And we will get back to that terminology some more. But first I want to talk about what are the four ways to represent these relations. You can represent them as XY pairs, or you can represent them as a mapping diagram. So you can see here, this 3 with the arrow to the 4 is representing an x of -3, taking you to a y of 4. Table of values, same thing. And then graphing, you plot your x values on the horizontal axis, y values on the vertical axis. Now the next vocabulary word I want you to see is a function. So a function is a relation that has each input going to exactly one output, all right? Only one output. So if we're looking to see, is the above relation a function or not? The thing that I notice are these 2 points right here, 4, -1 and 4, 3, because 4 is the input, and that input of 4 is going to two different outputs. It's going to -1 and it's going to 3. Or you can see the same thing here. It has 2 arrows leaving it. Now, that is going to make this not a function, okay? Because for a function, I should be able to give you an input. You should tell me exactly what the single output would be. You should be able to tell me what that output is. Here you can't, because it could be going to 2 different values. So that is going to make this one in particular not a function. The domain of a relation is a set of inputs, and the range is the set of outputs. So the domain, or the set of inputs, again, is talking about your x values. Your range, or set of outputs, those are going to be your y values, or f of x. Now, there are other ways of determining if something is a function or not. Another way to determine it is to use what's called the vertical line test, all right? The vertical line test, what it does is if you can draw any vertical line that goes through more than one point of a relation, then it is not a function. So I'm going to take us back up, and we're going to check out that vertical line test on the graph. Because what I want you to see is if I draw a vertical line right here, I'm intersecting that graph at those 2 points, all right? So because it intersects at those 2 points, it fails the vertical line test, all right? Which is another indicator of this no that we got right there, that is not a function. So that is another way we can use to determine if something is a function or not. So we're going to work on going between these types of writing relations. So we're going to start by writing the following ordered pairs as a mapping and graph them on the coordinate plane to determine if they represent a function. All right, so for a mapping, I have an input of 4 going to 2. I have an input of 3 going to -2. I have an input of 5 also going to -2. And I have an input of 2 going to 3. So that's what my mapping is going to look like, just listing the inputs and mapping where are they ending up with the outputs. Now, we can also graph these x and y points. So the first point, 4, 2, 1, 2, 3, 4, 1, 2. So there's that point. 3, -2, 5, -2, 2, 3, 4, 5, and it's going to go a little bit off. It's going to be about there. 2, 3. All right, so we want to determine whether or not this represents a function. Now, there's two ways that I'm going to discuss doing this. The first way, using that input-output table. Notice, if I tell you you have an input of 4, you know automatically your output is 2. I tell you you have an input of 3, you know automatically your output is -2. I tell you your input is 5, you can automatically tell me the output is -2. I give you input of 2, you can tell me you automatically have an output of 3. Any input I tell you, you can tell me without doubt what its output is. All right? So based on that, this is a function. Okay? Every input went to a single output, only one output. Now, don't let this fool you. Right here, different inputs can go to the same output. That is okay. It can still be a function that way, all right? It's a single input can't go to multiple outputs. Now, another way to see this is the vertical line test. If I were to draw vertical lines here, no matter where I draw my vertical line, it's only hitting a single point. It's only hitting my function once, or I should say my relation once for every vertical line. So because it passes the vertical line test, that's another indicator that it is in fact a function. Now it also wants us to list the domain and the range. Well, the domain are going to be the list of inputs, 4, 3, 5, and 2. The range is going to be my list of outputs, 2, -2, 3. All right, now moving to the next point. Does this relation pass the vertical line test? We already said yes. We've actually already tested that. That's what I did with my green lines. That was showing it passes the vertical line test because it only touches the relation once every time I draw a vertical line. So let's continue. Here, let's use the vertical line test. When you're looking at something graphically, your first thought should be using the vertical line test, okay? So when looking at graphs, think vertical line test, all right? So I'm just going to draw some lines in here. And now what I want you to notice, on A, no matter where I draw that vertical line, it only intersects once, okay? It only touches that relation once. So this one passes. And what does that mean? It is a function. In B, let's look at B. Well, when I draw my vertical line here, I want you to notice something. It's touching twice, okay? It intersects that C twice. And what that is telling me is this is failing the vertical line test. All right? It should only touch once if it's a function. So this one is not a function. And for C, again, draw a couple to convince yourself. But with every vertical line you draw, it's only touching that parabola once. Every time, only once. So what that's telling me is that passes the vertical line test. So that one is actually a function. All right. So example 3, y equals 5x plus 3 is an example of a function rule. Which letter would you consider to be the input? The input letter is also called the independent variable. The output letter is called the dependent variable. Well, so here all we're doing, we're adding in another vocabulary word for each of these things. All right? So, input, independent variable. Well, that is your x values. Your output, dependent variable. Those are your y values. And again, to wrap it back to some other vocabulary we already talked about, x is referencing the domain and y is referencing the range. Every one of those things are talking about the same thing. Each one has 4 ways of vocabulary to determine it. Now, what output would you get with an input of 2? Okay, well, there's that word input. So what that's telling me is my x is 2. And it wants to know what is my output. So my y is unknown. That's what we're trying to find. So this is just kind of a long-winded way of asking, what is y when x is 2? Well, let's use that equation. So y equals 5, where I'm letting x equal 2 plus 3. So 5 times 2 is 10. 10 plus 3, we're getting y equals 13 when x is 2. Right, and here, another way to write y equals 5x plus 3 is f of x equals 5x plus 3. So, and again, I've already touched on this, but f of x is just another way to write y. And it's something you've seen for a while now, so it's nothing too surprising to you. So, in example 4 here, we're going to work on using that notation. So, in A, when I say find f of 2, all that means is plug 2 in for every x you see in that equation, and that'll get you the output. So f of 2 means I'm plugging in 2 wherever I see an x. All right, well, 3 times 2 is 6, so this is going to be 4 minus 6, or give me an output of negative 2. F of negative 1, so 4 minus 3 times negative 1. Well, here, negative 3 times negative 1 is actually giving me a positive 3. Don't forget your double negatives. All right, 4 plus 3 gives me 7. F of 10. Again, same thing, just plugging in 10 where I see x. So 4 minus 30, or that gives me negative 26. All right, thank you so much for joining me for these notes. So please make sure you have them completely filled out, and then come back to class and we will do the practice work for this section.